Hello, my name is Abdelrahman and today I'll be explaining force system resultants. So, moment of a force. It's a measure of the tendency of the force to cause a body to rotate about the point or axis. Magnitude of moment depends on the force and the moment arm, which is perpendicular distance measured from the force line of action and point O. So as you can see in the three figures I provided below, A is the arm pushing the wrench at a 90-degree angle to rotate the bolt. Figure B, it's the same exact thing, but the arm is at an angle. So this is how we find it, with using the distance sine the angle which is provided. And figure C is basically you pulling the wrench does not actually exert any force or the moment force, or does not rotate the bolt. Moment of a force, scalar formation. For magnitude, MO equal FD multiplied by NM, where D is perpendicular distance from point O to its line of action of force. Direction, as a convention, we can consider counterclockwise moment is positive and clockwise moment is negative. As you can see in the figure I provided on the right, you can see that when the moment is going upwards, as you can see, or follow my hands, going to counterclockwise, it's positive. If it's going reverse, like reverse the figure, that's a negative. So as you can see here, this is an example I have provided. The point O is right there, the distance 5 meters, then there's 2 meters upward, and the force of 100 newtons going on a 3, 4, 5 triangle angle. And this is the answer. The point, or the moment of point O, is negative 4 over 5, as you can see, because it's clockwise, multiplied by 100 newtons, which is the force, multiplied by 2, minus 3 over 5, multiplied by 100, multiplied by 5. So the answer is negative 460 Newton meter, or basically 460 Newton meter. Moment of a couple. A couple is defined as two parallel forces that have the same magnitude but opposite directions and are separated by a perpendicular distance d. M equal Fd. As you can see in the example I provided, there is a guy holding a wheel from a distance of 0.4 meters with the same force of 30 newtons and 30 newtons. And the other example, which is from a distance of 0.3, but the force has increased to 40 newtons, which they both exert the same of 12 newton meter. For example, we have for figure 2, the man tries to open the valve by applying the couple forces of F equals 75 newtons to the wheel. Determine the couple moment produced. So as you can see here in the solution, negative 75 multiplied by 0.15 plus 0.15, which is the distance, which was provided in millimeters, but we have to get it in centimeters, which is 0.15, and negative 75 because it's the man is trying to open the valve by applying the couple forces. So, or we basically predict whether he's going clockwise or counterclockwise. So if the answer is negative 222.5, then we change it to positive because our assumption was wrong. It's supposed to be positive 75 multiplied by 0.15 plus 0.15. But the final answer is 22.5 Newton meter. So further simplification. Concurrent force system. A concurrent force system is where lines of action of all the forces intersect at a common point O. As you can see in the example I provided, Fr equals sigma F. Coplanar force system, lines of action of all the forces lie in the same plane. Resultant force of this system also lies in the plane. Resultant force Fr of perpendicular distance d produce same moment, as you can see in the figures I have provided on the right. So let's solve an example. For the assembly in figure 3, replace the loading system by an equivalent resultant force and moment acting at point A. So as you can see here, the drawing and the distance provided at each point, and the moment is actually given to us at 300 Newton meter. And we're supposed to replace the loading system by an equivalent resultant force and moment acting at point A. So this has multiple steps. So first we have to get the sigma fx by using 900 Newton sine 30, which equals 450 newtons. That is the fx, or the forces on the x-axis. And the forces on the y-axis, we have to do negative 900 cosine 30 minus 300, basically the force pushing downward, which equals 1079.42 newtons downwards. To get the FR, we have to use square root 450 squared plus 1079.42 squared, which will then equal 1169.47 newtons, or 1.17 kilonewton. Next step is we use the inverse tan rule, which is tan to the power of negative 1 multiplied by 1079.42 over 450, which equals 67.4 degrees. So to get the moment, or which is the final step before we getting our final answer, we have to do 300 minus 900 cosine 30 multiplied by 0.75 minus 300 multiplied by 2.25, which will equal negative 959.57 Newton meter, or 960 Newton meter clockwise moment. So as you can see, the three answers we got were 1.17 kilonewton, or basically what is the FR, and the theta, which is 67.4 degrees, and the moment of point A as we act is 960 Newton meter. Reduction of a simple distributed loading. Large surface area of a body may be subjected to distributed loadings. Loadings on the surface is defined as pressure. Pressure is measured in Pascal, PA. 1 PA equals Newton meter squared. Loading along a single axis. Most common type of distributed loading can be represented along a single axis. The pressure is multiplied by beam width so that the pressure varies only along the x-axis, as you can see in the examples I provided on the right. Reduction of a simple distributed loading. Magnitude of resultant force. Magnitude of dF is determined from differential area under the loading curve for length L, as you can see in the formula. Magnitude of the resultant force is equal to the total area A under the loading diagram, as you can see also in the example I provided. Reduction of a simple distributed loading. Location of resultant force. dF produces a moment of xdF equal xwx dx sub O for the entire plate, as you can see in the example I provided for you and the equations that are used. So let's take an example. For figure 5, replace the loading system by an equivalent resultant force. Specify where its location. As you can see the diagram, 6 kilonewton meter from point A, 3 kilonewton meter on point C, and 6 kilonewton meter on point B. The distance from the 6 kilonewton on A and the mid is 3 meters, and the same for 3 to B. Let's go to the next slide and see the solution. So the equivalent resultant force on couple moment upon point A. Basically we're going to do FR equals negative half multiplied by 3 multiplied by another 3 with the distance, minus 3 multiplied by 6 minus half over 3 minus half multiplied by 3 over 3. The answer should be brought up as negative 27 kilonewtons, or 27 kilonewtons downwards. Summing the moments about point A. So the moment is all the forces. So negative half multiplied by 3 multiplied by 3 multiplied by 1 minus 3 multiplied by 6 multiplied by 3 minus half multiplied by 3 multiplied by 3 multiplied by 5. which then gets us the answer of negative 81 kilonewtons or 81 kilonewton meter clockwise, which is also the negative moment. As you can see, to make it easier, I have provided a figure below, which makes it easier to where we got the numbers from. I hope this video has helped you understand of the force system resultant, and I hope to see you next time. Thank you very much.